ಹಾಯ್, ಹೌ ಆರ್ ಯು ಆಲ್? 10th ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಓದ್ತಾ ಇರೋ ಮಕ್ಕಳು, ಆಲ್ 10th ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಸ್ಟೂಡೆಂಟ್ಸ್. I feel you people are in the note of preparation for the exam, is it not? So, with reference to that, we from Gurudev Academy, we have come up with a very interesting kind of notion. Okay, here we are going to cover some of the questions from SSLC model question papers, and one of my colleague has already discussed with model paper 2, so I'll be going ahead with model paper 1. Okay, so in this model paper I'll be addressing to the questions which have been asked under physics part ninda matra ನಾನು ಆನ್ಸರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ನಮ್ಮ ಮೇನ್ ಉದ್ದೇಶ ಏನಪ್ಪ ಅಂತಂದರೆ ವಿ ಶುಡ್ ಹ್ಯಾವ್ ಅ ಲಾಟ್ ಆಫ್ ಫನ್ along with the studies, right? So exam time we should not get tensed, we should have a lot of fun, so hence fun can be obtained with the help of physics, so hence physics ka funda. Okay, so let us start off with our discussion. So in this lot I have picked my first question like this: center of spherical mirror. Now whenever I consider a spherical mirror, my dear friends, spherical mirror ತಗೊಂಡ್ರೆ ಸ್ಪೆರಿಕಲ್ ಮಿರರಲ್ಲಿ ಅದರ ಸೆಂಟರು ಏನಾಗಿರುತ್ತೆ ಅಂತ ಕೇಳಿದೆ ಇಲ್ಲಿ ಕ್ವೆಶನ್ ಅಲ್ವಾ. ಸೊ ವಿ ಆಲ್ರೆಡಿ ನೋ ದ್ಯಾಟ್ ಇಫ್ ಐ ಟೇಕ್ ಎನಿ ಸ್ಪೆರಿಕಲ್ ಮಿರರ್ ಲೈಕ್ ದಿಸ್ ಕಾನ್ಕೇವ್ ಮಿರರ್, ಸೊ ದ ಮಿಡ್ ಪಾಯಿಂಟ್ ಆಫ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಮಿರರ್ ಐ ಮಾರ್ಕ್ ಇಟ್ ಆಸ್ ವಾಟ್? ಪೋಲ್. ಸೊ ಅವರ್ ಆನ್ಸರ್ ಇಸ್ ಪೋಲ್ ಹಿಯರ್. ಓಕೆ, so answer is option B, pole. Let us go to next question. So here another question which has been asked is Ohm's law gives the relationship between, ನಮ್ಮ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಲ್ಲೇ ಇದೆ. What is that? Current flowing through a conductor is directly proportional to potential difference between the ends of the conductor. Okay, so according to NCERT they say that potential difference is directly proportional to current. Okay, so hence ಇಲ್ಲಿ ಯಾವ ರಿಲೇಷನ್ ಬರ್ತಾ ಇದೆ? We can very clearly see that potential difference and electric current, ಇವು ಎರಡರ ಮಧ್ಯದಲ್ಲಿರುವಂಥ ರಿಲೇಷನ್. ಸೊ ಹೆನ್ಸ್ ಐ ಕ್ಯಾನ್ ಪಿಕ್ ದಿಸ್. ಓಕೆ, ಸೊ ಹೆನ್ಸ್ ಅವರ್ ಆನ್ಸರ್ ಶುಡ್ ಬಿ ವಾಟ್? ಆಪ್ಷನ್ ಸಿ ಹಿಯರ್, ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಆ್ಯಂಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್. ಅರ್ಥ ಆಯ್ತಾ ಮಕ್ಕಳೇ? ಲೆಟ್ಸ್ ಮೂವ್ ಆನ್ ಟು ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶನ್. Now in this particular question they are asking us, draw the symbol diagram of rheostat or a variable resistance used in an electric circuit. Okay, so ರಿಯೋಸ್ಟ್ಯಾಟ್ ಅಂದ ತಕ್ಷಣ ನಮ್ಮ ತಲೆಯಲ್ಲಿ ಬರೋದು ವೇರಿಯಬಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ರಿಯೋಸ್ಟ್ಯಾಟ್ ಇರೋದೇ ಮಲ್ಟಿಪಲ್ ಟರ್ನ್ದು ಒಂದು ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಅದು. ಸೊ ಅದರಿಂದ ನಾನು ರೆಸಿಸ್ಟೆನ್ಸ್ನ ವೇರಿ ಮಾಡ್ಬೋದು. ಐ ಕ್ಯಾನ್ ವೇರಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಕಂಫರ್ಟಬಲಿ. ಓಕೆ, ನಾವು ವಿ ಕ್ಯಾನ್, as per our NCERT we have this symbol, my dear friends. Okay, either you can draw this or this. ಇವು ಎರಡರಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ಸಿಂಬಾಲನ್ನು ನೀವು ಯು ಕ್ಯಾನ್ ಡ್ರಾ. ಓಕೆ, ಫೈನ್. ಸೊ ರಿಯೋಸ್ಟಾಟ್ನ ಸಿಂಬಾಲ್ ವಿ ಹ್ಯಾವ್ ಮಾರ್ಕ್ಡ್ ಇಟ್. ನಾವು ಲೆಟ್ಸ್ ಗೋ ಹೆಡ್ ಆ್ಯಂಡ್ ಟೇಕ್ ಅ ಲುಕ್ ಎಟ್ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶನ್. ರೈಟ್ ಎನಿ ಟೂ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್. ಓಕೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಅಂದ ತಕ್ಷಣ ವಾಟ್ ಡು ಯು ರಿಮೆಂಬರ್? ಬೇಗ ಹೇಳಿ ಪಟ್ ಅಂತ ಹೇಳಿ. ಎಸ್, ಡೆಫಿನೆಟ್ಲಿ ಇಟ್ ಈಸ್ ಮ್ಯಾಗ್ನೆಟ್. ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ತೊಗೊತೀವಿ. ವಿ ಜಸ್ಟ್ ಸ್ಪ್ರಿಂಕಲ್ ಸಮ್ iron filings around it, then we see that its arrangement is somewhat in an oblonged manner. So definitely this arrangement we call it as what? Magnetic field line. Okay, so magnetic field line na properties na bariyovaga we will be considering. Now I am just indicating whatever I had narrated here. Okay, now let's go ahead and take a look at the concept of magnetic field lines first. Okay, so I am showing a bar magnet. Okay, in this bar magnet, as you can see that from this bar magnet, if you just move out of this bar magnet, these lines which have been shown here, now these are the curved lines. Okay, now these curved lines, they are coming out from which pole? They are coming out from north pole, is it not? Okay, and they are entering into which pole? South pole. And you are seeing that this is happening outside the magnet. What about inside the magnet? Inside the magnet again these lines are continuing. Okay, so definitely they are moving from south pole to north pole. So hence I can very easily state our first property in this manner. So if you just try to take a look at first property, what we can write? Magnetic field lines are the imaginary lines. Definitely these are not real, okay? These are the imaginary lines. For our theoretical conceptual understanding, we just follow this, and Michael Faraday ಅವರು ಇದನ್ನ ಇನ್ವೆಂಟ್ ಮಾಡಿದ್ದು, ಅಂದರೆ like he stated that we can use magnetic field lines ಅಂತ, okay? So these are the imaginary lines, okay? Starting from which pole? From north pole and enter south pole outside a magnet, okay, and move from south pole to north pole inside a magnet. Hence they form what? A continuous closed loop. Okay, so ಇಲ್ಲಿ key terms ನಾನು ಇಲ್ಲಿ ನಿಮಗೆ yellow color ಅಲ್ಲಿ ತೋರಿಸಿದ್ದೀನಿ. You just remember these key terms. Okay, continuous closed loop, that is our first proprietary property that you have to remember, and these are what? These are the imaginary lines. Remember this. Okay, then of course second property is very clearly understandable, that magnetic field lines never intersect. Now ಇಲ್ಲಿ ನೋಡಿ ಮಕ್ಕಳೇ, in this if you just observe, no magnetic field line is like getting intersected in between, okay? So this is clearly because using a magnetic field line I can understand the direction of magnetic field, okay? Suppose if two magnetic field lines intersect, let me just show it to you. ಸೊ ಇಲ್ಲೇನಾಗ್ತಾ ಇದೆ, ಸಪೋಸ್ ಇಲ್ಲಿ ಒಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ ಇದೆ, ಓಕೆ, ಈ ಥರ ಹೋಗ್ತಾ ಇದೆ ಅಂದ್ಕೊಳ್ಳಿ. ದೆನ್ ದೆರ್ ಈಸ್ ಒನ್ ಮೋರ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ ಇನ್ ದಿಸ್ ಮ್ಯಾನರ್, ಓಕೆ. ನೌ ಇಫ್ ದೇ ಇಂಟರ್ಸೆಕ್ಟ್, at the point of intersection I can see that there I can draw two tangents here. ಒಂದು tangent ಇಲ್ಲಿಗೆ ಬಂದರೆ ಇನ್ನೊಂದು tangent ಇಲ್ಲಿಗೆ ಬರ್ತಾ ಇದೆ, and note that tangent will always give me the direction of magnetic field, okay. So you can clearly see that at one point there will be two directions. Is it possible? Can a physical quantity like magnetic field have two simultaneous directions at the same time, at the same point? Definitely no. So it is impossible. So hence definitely we are going to consider here, we are not going to consider the intersection. So clearly we can understand that two magnetic field lines, they never intersect, okay. Coming to the next, they have same strength. So that means their strength is same throughout. That means if you just move about any one of the magnetic field line here, okay, if you just move about any one of the magnetic field line, each magnetic field line will indicate a strength, okay, as well as if you just come closer to the pole, strength will be high. If you just move away from the pole, strength will be low. So definitely closer to the magnetic poles, strength is high, so that means it is uniform. So definitely magnetic field lines should also have same strength, okay. So these are three predominant properties which I thought of listing them, because these are the main points that they have given in your NCERT textbook, okay. Let's go ahead and take a look at next question, okay. What is hypermetropia? Okay, mention two causes for it. So dear friends, I am wearing a spectacle, hope you can see that, okay. I am wearing it not because of hypermetropia, okay, because I am unable to see far off things. So in order to see those far off things clearly, I am using spectacle, okay, whereas hypermetropia is the reverse of it. In this case what happens, the nearby objects, they appear to be blur, they will not be clear to me, okay. So hence in that situation we are going to correct it, and this is one of the defect in the eye, that's what we have, okay. So accordingly hypermetropia, as I was mentioning to you, okay, we can write it as what? Human eye which can see far off objects or distant objects clearly, okay. Distant objects na clear agi nodakagutte kannige, okay, but cannot see the nearby objects clearly. Nearby objects na nodakagalla clear agi, okay, is said to be suffering with hypermetropia, or we also call it as long sightedness. ಯಾಕೆ ಲಾಂಗ್ ಸೈಟೆಡ್ನೆಸ್ ಅಂತ ಕರಿತಾ ಇದ್ದೀವಿ ಇಲ್ಲಿ? ಲಾಂಗ್ ಸೈಟೆಡ್ನೆಸ್ ಇಂಡಿಕೇಟ್ಸ್ ದಟ್ ಹ್ಯೂಮನ್ ಐ ಕ್ಯಾನ್ ಸಿ ಫಾರ್ ಆಫ್ ಥಿಂಗ್ಸ್ ಕ್ಲಿಯರ್ಲಿ. ಸೊ ಲಾಂಗ್ ಸೈಟೆಡ್ ಇದೆ ಅಂತ ನಾನು ಹೇಳ್ಬೋದಲ್ವಾ. ಓಕೆ, ಸೊ ಲಾಂಗ್ ಸೈಟೆಡ್ನೆಸ್. ಸೊ ಇದಕ್ಕೆ ಇನ್ನೊಂದು ಹೆಸರೇನು, ಹೈಪರ್ಮೆಟ್ರೋಪಿಯಾ. ಓಕೆ, ಆ್ಯಂಡ್ ಮೆನ್ಷನ್ 2 ಕಾಸಸ್ ಫಾರ್ ಇಟ್. ಕಾಸ್, 2 ಕಾಸ್ ತುಂಬ ಸಿಂಪಲ್ ಆಗಿದೆ. ಸೊ ಫಸ್ಟ್ ಕಾಸ್ ನೋಡಿ, ಇಲ್ಲಿ ವಿ ಕ್ಯಾನ್ ಸಿ ದ್ಯಾಟ್ ಇಟ್ ಈಸ್ ಮೇನ್ಲಿ ಬಿಕಾಸ್ ಆಫ್ ಇನ್ಕ್ರೀಸ್ ಇನ್ ಫೋಕಲ್ ಲೆಂತ್ ಆಫ್ ದ ಐ ಲೆನ್ಸ್. ಐ ಲೆನ್ಸ್ ಇದೆ ಅಲ್ವಾ, ಐ ಲೆನ್ಸ್ದು ಫೋಕಲ್ ಲೆಂತು ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಓಕೆ, ವೆನ್ ದ ಐ ಈಸ್ ಫುಲ್ಲಿ ರಿಲ್ಯಾಕ್ಸ್ಡ್, ಲೈಕ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಾನು ನಿಮ್ಮನ್ನು ನೋಡ್ತಾ ಇದ್ದೀನಿ ಇವಾಗ. ಓಕೆ, ಐ ಆಮ್ ರಿಲ್ಯಾಕ್ಸ್ಡ್. Why am I relaxed? Because as a teacher, I will always feel relaxed in front of my students. Is it not? So, whenever I am having a relaxed observation, in that case, if I am hypermetropic, my eye lens will have a longer focal length. So that ನನಗೆ ದೂರದ್ದು ಕಾಣಿಸ್ತಾ ಇದೆ ಬಟ್ ಹತ್ತಿರದಲ್ಲಿ ಬ್ಲರ್ ಆಗಿ ಕಾಣ್ತಾ ಇದೆ. ದಟ್ಸ್ ವಾಟ್ ಐ ಮೀನ್. ಓಕೆ, ದೆನ್ ಸೊ ಒಂದನೇ ಕಾಸ್ ಗೊತ್ತಾಯ್ತಲ್ವಾ. ಫಸ್ಟ್ ಕಾಸ್, increase in focal length of the eye lens when the eye is fully relaxed. Okay, this is our first point, first cause. Second cause, we can clearly understand here, decrease in length of the eyeball na length kadame agutte. Okay, as if distance of retina from the eye lens has decreased. Very simple. Okay, ಎರಡು ಕಾಸು ಕ್ಲಿಯರ್ ಆಗಿ ಅರ್ಥ ಮಾಡಿಕೊಂಡು ಪರ್ಫೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಓಕೆ, ಡೆಫಿನೆಟ್ಲಿ ಇದು ಎಕ್ಸಾಮಲ್ಲಿ ಬರುವಂಥ ಕ್ವೆಶನ್. ಸೊ ಐ ಬೆಟ್ ಆನ್ ಇಟ್. ಡೆಫಿನೆಟ್ಲಿ ದಿಸ್ ಕ್ಯಾನ್ ಬಿ ಆಸ್ಡ್. ಪ್ಲೀಸ್ ಬಿ ಶ್ಯೂರ್ ಆಫ್ ಇಟ್. ಓಕೆ, ಸೊ ಅರ್ಥ ಆಯಿತು ಅಂದ್ಕೊಂಡಿದ್ದೀನಿ. ಸೊ ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಪಾಸ್ ದ ವಿಡಿಯೋ ಆ್ಯಂಡ್ ಮೇಕ್ ಅ ನೋಟ್ ಆಫ್ ದಿಸ್. ಓಕೆ, 5, 4, 3, 2, 1. Let's start. Okay, now let me move on to next question. Right, so next question ನೋಡಿ ಮಕ್ಕಳೇ, very simple one, very interesting one. Observe the circuit diagram given below, answer the questions given. Okay, so ಇದು ಸರ್ಕ್ಯೂಟ್ ಇದೆ ಈ ಥರ ಒಂದು. ಓಕೆ, ಇಲ್ಲಿ ನೋಡಿ ಒಂದು ಕಾಯಿಲ್ ಇದೆ. ಈ ಕಾಯಿಲ್ನ ನಾವು ಒಂದು ಬ್ಯಾಟ್ರಿಗೆ ಕನೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. ಓಕೆ, ಆ್ಯಂಡ್ ವಿ ಸಿ ದ್ಯಾಟ್ ದ ಕರೆಂಟ್ ಇಸ್ ಫ್ಲೋಯಿಂಗ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್. ಕರೆಂಟ್ ಯಾವ ಡೈರೆಕ್ಷನಲ್ಲಿ ಫ್ಲೋ ಆಗ್ತಾ ಇದೆಪ್ಪ, ಇಲ್ಲಿ ನೋಡಿ, ಟಿಕ್ 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 ಟಿಕ್, ಕ್ಲಾಕ್ ವೈಸ್. ಕರೆಂಟ್ ಇಸ್ ಫ್ಲೋಯಿಂಗ್ ಇನ್ ಕ್ಲಾಕ್ ವೈಸ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ವಾ, ಕರೆಕ್ಟ್. ಓಕೆ, ಫಸ್ಟ್ ಕ್ವೆಶನ್ ಈ ಥರ ಇದೆ ನೋಡಿ. ಇಲ್ಲಿ ಮೆನ್ಷನ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ದಟ್ ಫಾರ್ಮ್ಸ್ ಅರೌಂಡ್ ಅಟ್ ದ ಪಾಯಿಂಟ್ಸ್ ಎಕ್ಸ್ ಆ್ಯಂಡ್ ವೈ. ಎಕ್ಸ್ ಮತ್ತು ವೈ ಪಾಯಿಂಟಲ್ಲಿ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಹೇಗಿದೆ, ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್ ಅಸ್. ಓಕೆ, ಸೊ ಇವಾಗ ವಾಟ್ ಐ ವಿಲ್ ಡೂ ಇಸ್ ಐ ವಿಲ್ ಜಸ್ಟ್ ಡ್ರಾ ಅ ಟ್ಯಾಂಜೆಂಟ್ ಹಿಯರ್ ಅಟ್ ಪಾಯಿಂಟ್ ಎಕ್ಸ್. ಐ ಆಮ್ ಡ್ರಾಯಿಂಗ್ ಅ ಟ್ಯಾಂಜೆಂಟ್. ಸಪೋಸ್ ದಿಸ್ ಇಸ್ ಅ ಟ್ಯಾಂಜೆಂಟ್. ಓಕೆ, and direction given to the tangent is same as direction of current direction. ಅರ್ಥ ಆಯ್ತಲ್ವಾ, ಕರೆಂಟ್ ಡೈರೆಕ್ಷನ್ ಕ್ಲಾಕ್ ವೈಸ್ ಇದೆ. ಸೊ ಡೆಫಿನೆಟ್ಲಿ ಆರೋ ಕೂಡ ನಾನು ಈ ಟ್ಯಾಂಜೆಂಟ್ಗೆ ಅಪ್ವರ್ಡ್ ಕೊಡ್ತಾ ಇದ್ದೀನಿ ಇಲ್ಲಿ ಪಾಯಿಂಟ್ ಎಕ್ಸಲ್ಲಿ, ಯಾಕಂದರೆ ಕರೆಂಟ್ ಈ ಥರ ಹೋಗ್ತಾ ಇದೆ. ಸೊ ಡೆಫಿನೆಟ್ಲಿ ದಿಸ್ ಇಸ್ ದ ಆರೋ ದ್ಯಾಟ್ ಐ ಆಮ್ ಗಿವಿಂಗ್. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ನೋಡಿ, ಹಿಯರ್ ದಿಸ್ ಇಸ್ ಅ ಟ್ಯಾಂಜೆಂಟ್. ನಾವು ಐ ವಿಲ್ ಯೂಸ್ ಅ ರೂಲ್ ಕಾಲ್ಡ್ ಆಸ್ ರೈಟ್ ಹ್ಯಾಂಡ್ ಥಂಬ್ ರೂಲ್. ರೈಟ್, ಸೊ ಇಲ್ಲಿ ಆರೋ ಇದೆ, ಈ ಥರ ಕಾಣಿಸ್ತಾ ಇದೆ ಅಲ್ವಾ. ಫೈನ್. ಸೊ ಇಲ್ಲಿ ನೋಡಿ, ಐ ಶುಡ್ ಪಾಯಿಂಟ್ ಮೈ ಥಂಬ್ ಇನ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ಆರೋ ಡೈರೆಕ್ಷನಲ್ಲಿ ಥಂಬ್ನ ಪಾಯಿಂಟ್ ಮಾಡಿದೆ. ದೆನ್ ಐ ಕರ್ಲ್ ಮೈ ಫಿಂಗರ್ಸ್ನ ಕರ್ಲ್ ಮಾಡಿದೆ ಅರೌಂಡ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಟ್ಯಾಂಜೆಂಟ್. ಅವಾಗ ಏನಾಯ್ತು ನೋಡಿ, ಹೌ ಆಮ್ ಐ ಗ್ರಿಪ್ಪಿಂಗ್ ದ ಕಂಡಕ್ಟರ್? ಐ ಆಮ್ ಗ್ರಿಪ್ಪಿಂಗ್ ಇಟ್ ಲೈಕ್ ದಿಸ್. ಈ ಥರ ಗ್ರಿಪ್ ಮಾಡ್ತಾ ಇದ್ದೀನಲ್ವಾ. ಸೊ ಡೆಫಿನೆಟ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಆರ್ ಎಂಟರಿಂಗ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ಲಿ ಇನ್ ಟು ದ ಸ್ಕ್ರೀನ್. ಅರ್ಥ ಆಯ್ತಾ? ನಿಮ್ಮ ಕಡೆಯಿಂದ ಇವಾಗ ನೀವು ಮೊಬೈಲ್ ಮುಂದೆ ಕೂತ್ಕೊಂಡಿದ್ದೀರಾ. ಸೊ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಹೇಗೆ ಬರ್ತಾ ಇದೆ, ನಿಮ್ಮ ಕಣ್ಣಿನಿಂದ ಸ್ಕ್ರೀನ್ ಒಳಗಡೆ ಹೋಗ್ತಾ ಇದೆ. ದ್ಯಾಟ್ ಈಸ್ ಹೌ ಐ ಕ್ಯಾನ್ ಸಿ ಫ್ರಮ್ ಯುವರ್ ಐ ಇಟ್ ಈಸ್ ಎಂಟರಿಂಗ್ ಇನ್ ಟು ದ ಸ್ಕ್ರೀನ್. ದಿಸ್ ಇಸ್ ಹೌ ಐ ಕ್ಯಾನ್ ಕ್ಲಿಯರ್ಲಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ರೈಟ್ ಹ್ಯಾಂಡ್ ಥಂಬ್ ರೂಲ್ ನೋಡಿ, room, 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 easily. We can very easily find the direction, is it not? Now let me come to point y. Point y ನಲ್ಲಿ ಇನ್ನೊಂದು ಟ್ಯಾಂಜೆಂಟ್ ಡ್ರಾ ಮಾಡಿದ್ದೀನಿ. ಓಕೆ, ಸೊ ಪಾಸ್ ಮಾಡ್ಕೊಂಡು ನೀವೇ ಆನ್ಸರ್ ಮಾಡಿ ಇದನ್ನು. ವೆರಿ ಈಸಿಲಿ ಐ ಕ್ಯಾನ್ ಸಿ ದ್ಯಾಟ್ ಟ್ಯಾಂಜೆಂಟ್ ಇಸ್ ಇನ್ ದ ಡೌನ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್. ಓಕೆ, ನಾನು ಥಂಬ್ನ ಐ ಶುಡ್ ಪಾಯಿಂಟ್ ಇನ್ ವಾಟ್ ಡೈರೆಕ್ಷನ್, ಇನ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ಆರೋ. ಸೊ ಥಂಬ್ನ ಪಾಯಿಂಟ್ ಮಾಡಿದೆ, ಕರ್ಲಿಂಗ್ ಮೈ ಫಿಂಗರ್ಸ್. ಸೊ ಯಾವ ಥರ ಹೋಗ್ತಾ ಇದೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್, ಈ ಥರ ಒಳಗಡೆ ಎಂಟ್ರಾಗಿ ಇಲ್ಲಿಂದ ವೈ ಪಾಯಿಂಟ್ನಿಂದ ಹೊರಗೆ ಬರ್ತಾ ಇದೆ. ಸೊ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ಲಿ outward. That means magnetic field lines are coming out of your mobile screen and entering into your eye. Okay, so this is how I can understand the direction. Very simple approach, is it not? So you just have a look at the answer what I have written, the same thing which I have explained to you, is it not? At point X, what happens here? Magnetic field will be directed perpendicularly out of the screen. Okay, that means they will be towards you, while at Y it will perpendicularly into the screen or it is away from you. Okay, so this is how I can very clearly understand the direction, my dear friends. Okay, just pause ಮಾಡಿ. We can see so you can see that at point Y magnetic field will be directed perpendicularly out of the screen. Okay, whereas at point X we can see that it is perpendicularly away from you, perpendicularly into the screen. So ee tara barta ide, we can clearly understand that. Okay, so let's move on to next part now. Next question ನೋಡ್ಕೊಳ್ಳಿ. ಈಗ ಎರಡನೇ ಕ್ವೆಶ್ಚನ್ ಏನು ಕೇಳ್ತಾ ಇದೆ, ಸ್ಟೇಟ್ ದ ರೂಲ್ ದಟ್ ಹೆಲ್ಪ್ಸ್ ಟು ಡಿಸೈಡ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಸೊ ವಾಟ್ ಇಸ್ ದ ರೂಲ್ ದಟ್ ವಿ ಯೂಸ್ಡ್ ಹಿಯರ್? ರೈಟ್ ಹ್ಯಾಂಡ್ ಥಂಬ್ ರೂಲ್. ಸೊ ವಾಟ್ ಇಸ್ ರೈಟ್ ಹ್ಯಾಂಡ್ ಥಂಬ್ ರೂಲ್? Right hand thumb rule is like point your thumb in the direction of the current, okay, and your fingers will curl in the direction of magnetic field. So definitely ee taradalli now rule na baribodu. You just pause the video and write it down. Okay, fine. So let's move over to next question quickly. Now we have this seventh question, very interesting question. Connecting electrical appliances in parallel in domestic electric circuit is better. Give reason. Okay, see, parallel combination, the moment I say about parallel combination of resistances, whenever I consider, what are the things that you can remember? First thing you should remember, in parallel combination what is same? Potential difference across the two resistors is same. Second thing, current is different, current will get divided into number of branches that we have, right? So this is second point. So note that in parallel combination, individual branch will have individual current, whereas potential difference across every part of that parallel combination will be what? Same. So ಇದೇ ಅಡ್ವಾಂಟೇಜ್ ಅಲ್ವಾ? ದಿಸ್ ಇಸ್ ದ ಅಡ್ವಾಂಟೇಜ್. ಓಕೆ, ಸೊ ಹೌ ಐ ಕ್ಯಾನ್ ರೈಟ್ ದ ಅಡ್ವಾಂಟೇಜ್? ಯು ಕ್ಯಾನ್ ಸಿ ದಟ್ in parallel circuit we have each appliance has its own separate path. Okay, its own separate path we have. Okay, and for current we have separate path and allowing independent operation and switching. We can clearly see that independently, say suppose we have first appliance here, second appliance here, and both the appliances are getting different currents, then don't you see that this can operate separately as compared to this one? Why? Because they are carrying two different currents, and I can very easily understand that suppose this particular pen, it requires 3 ampere current, and there is one more particular pen which requires 2 ampere current. Okay, then by using parallel combination I will be able to supply exactly 3 ampere in first one, upper one, and exactly 2 ampere in the lower one. So definitely they can independently operate, they do not depend on each other, is it not? So this is one of the advantage, right? Okay, so this is first advantage. Second thing, before I just list down the second advantage, we should remember that in parallel grouping voltage is same and is equal to what? Equal to voltage of the source. Suppose you connect a battery has a voltage of 10 volt. Okay, then in parallel combination every resistance will have 10 volt of voltage, so across every resistance. So definitely this is one of the advantage, and because of that reason we can see that each of the appliance receives a full mains voltage will be there so that all the appliances can work at their rated power completely. Rated power nalle work madak chance sigutte because they are getting complete voltage, no? So definitely they can work under their rated power. What is rated power? Rated power is I square R into T or V into I. Okay, I square R is, it is the operation power, V into I is called as rated power. So definitely now they can very easily operate with the rated power completely. Yaudu loss agdira, they can completely work. So this is how we can understand the advantage. Now let me go to next one. Before I move on, you just make a note of this, pause the video, note these 2 points. Okay, hopefully you will do that. Now let me move on to next question quickly. Now this question is based on ray optics. Okay, light chapter. Okay, so the ray diagram for image formation in convex lens when the object is placed at 2f1, mention the position and nature of the image formed. Very simple thing. See, object is placed at 2f, then image will be formed at where? 2f only, right? So definitely I can draw the ray diagram in this manner. Now you can see object is placed at 2f1, okay, image is formed at 2f2, okay, and accordingly we can see that size of image and size of object, if you just observe, they are same and image is inverted with respect to object. Okay, so and what kind of image we are getting? We are getting image behind the lens, so for that reason it will be what? A real image, is it not? Okay, so this is the ray diagram and nature of the image, I am just mentioning it here. Object at 2f1 will produce image at 2f2 and size of image will be same as the object. Okay, next, nature of image, we can clearly see that nature of image is real and inverted. Hopefully you followed this. Okay, so I'll just give you some time, you just make a note of this by pausing the video. Okay, chalo, let's move on. Now let me consider next question. Now, what is dispersion of light? Dispersion of light ಅಂದ ತಕ್ಷಣ ನನ್ನ ತಲೆಯಲ್ಲಿ ಈ ಥರ ಬರುತ್ತೆ. So I always think dispersion like this. Suppose I take a pipe carrying white light, okay, white liquid, and if I just pass it through a prism, we will get 7 different colors coming out from the other surface. So this is dispersion, my dear friends. Okay, so hence what is dispersion? Dispersion happens to be the phenomenon of splitting of white light into 7 colors when it passes through a glass prism. Okay, this is known as dispersion. So how many colors it will split? 7 colors. What are they? Violet, indigo, blue, green, yellow, orange, red, vibgyor. Okay, so these are the 7 different colors, and the order in which I have mentioned all these colors, they are in the increasing order of their wavelength. Wavelength keeps on increasing, and red has highest wavelength and violet has least wavelength. This is how we have dispersion, my dear friends. And just to narrate it properly, now you can see white light that is getting dispersed into 7 fundamental colors. I hope it is clear. Okay, now let me move on to next question. Explain the formation of rainbow. Rainbow ಯಾವ ಥರ ಫಾರ್ಮ್ ಆಗುತ್ತೆ? ರೇನ್ಬೋ ನೋಡಿದ್ದೀರಾ ಎಲ್ಲರೂ? ನೋಡಿದ್ದೀರಾ? ಓಕೆ, ನನಗೆ ಯಾವಾಗಲೂ ರೇನ್ಬೋ ಅಂದ ತಕ್ಷಣ ಐ ಜಸ್ಟ್ ರಿಮೆಂಬರ್ ಒನ್ ಥಿಂಗ್, ಲೈಕ್ ವೆನ್ ಎವರ್ ಐ ಸಿ ಮೈ ಮಾಮ್ ಆ್ಯಂಗ್ರಿ, ಓಕೆ, she comes and gives me a tight slap, so rainbow nazar aayega. Okay, I'll get a rainbow in front of my eyes, right? But physics, it is not like this, my dear friends. Rainbow is nothing but it is the after cause of dispersion, refraction and reflection. Okay, so let's go ahead and take a look at this. Before I answer, just enjoy this nature's beauty, how beautiful the nature is it not? Now here we have the rainbow that is formed, and there are 2 different types of rainbows that you will study in your PU1, PU2, class 12. Okay, but right now I will be just considering a simple rainbow. Okay, now what is rainbow? Rainbow is a natural spectrum appearing in the sky after a rain shower. Natural spectrum. Okay, when you pass white light through prism, there you will get 7 fundamental colors, no? That is called a spectrum. Okay, so it is a natural spectrum. Then next thing, you must mention this. It is caused by what? It is caused by dispersion of sunlight by tiny water droplets present in the atmosphere. Okay, then using this, we should say, how can I see rainbow? So next thing, rainbow is always formed in a direction opposite to that of what? Sun. In the direction opposite to sun. Suppose sun is behind me, I should see rainbow here. Okay, this is what we have, right? Then next thing, continuing with the next thing. Now if you just notice here, sunlight, it is falling onto a raindrop. I am just considering a spherical raindrop. In that sunlight enters, and because of first surface, okay, there will be a splitting up of two colors here. I am just indicating that red and violet, and then again inside this raindrop it will get internally reflected. Okay, then again it comes out from the same surface through which it has entered in, and thus it will get deviated more, so that we will be able to see two different colors. You can see here two distinctive colors we can very clearly see in case of a rainbow. So this is how we have. So as you can see, refraction, reflection, refraction. This is how rainbow is formed. Very simple, na? Very simple. Okay. So refraction, reflection, refraction, right? Okay. R, triple R, right? Okay. Triple R ಅಂದ ತಕ್ಷಣ ಮತ್ತೆ ನಾಟು ಅಲ್ಲ. This is rainbow. Okay. Chalo. Let's move on to the sentence that we should write. Please manage this writing in this proper manner. Okay. The water droplet acts like a small prism, is it not? It is acting like a small prism here. They refract and disperse the incident sunlight, okay, then reflect it internally and finally refract it again when it comes out of the raindrop. That's what we have indicated in the diagram. So ee diagram na print hakitkombidi taleli. You can forget your name, but you should not forget this. Okay, promise? Chalo, let's go ahead. Now due to the dispersion of light and internal reflection, different colors reach the observer's eyes. That's it. Simple. Is it not very simple? Okay. Now this is the clear cut description which is given in your textbook. I followed the same thing and I've simply modified it by a bit. Okay. Just make a note of these points. Okay. Then I'll just move ahead. I think we have come to the next part of this question paper. Here we have the next question, that is laws of refraction has been asked. State laws of refraction. Okay. Now first law and the second law. There are two laws in refraction. First law we call it as the law of planes. Okay. Second law it is called as Snell's law. Okay. Let us go ahead and understand these two laws very quickly. Okay. First law, how do we state it? Definitely you all would be knowing incident ray, refracted ray and normal drawn at the point of incidence all lie in the same plane. So that means everything is coplanar. All these rays will be in one single plane. So law of coplanarity. Okay. Then second law, it says what? Ratio of sine of angle of incidence to sine of angle of refraction is always a constant for a given pair of media, and it is known as a refractive index of medium 1 with respect to medium 2. So we just mention it in this manner. And this second law, as I was telling to you, it is known as what? Snell's law. Okay, Snell's law. Snell is the scientist who invented this particular law, and he showed it experimentally as well. Okay. Let's move on to next one. A ray of light traveling in kerosene enters obliquely into water. Does that light ray bend towards the normal or away from the normal? Why? They are asking. Okay. Practical question. Suppose you take a bucket filled with water. In that water, you spill some kerosene. Kerosene, will it go below the water surface or will it float on the water surface? Quickly ಹೇಳಬೇಕು ಹೇಳಿ. Kerosene floats on the surface. So very clearly kerosene becomes a denser medium, whereas water becomes a rarer medium. So hence light traveling from denser medium to rarer medium, how will it bend? It will bend away from the normal. So this is the reason that we have. Okay, I need not go ahead and mention this. Okay, so ಈ ಕ್ವೆಶನ್ಗೆ ಆನ್ಸರ್ ಗೊತ್ತಾಗಿದೆ ಅಂದ್ಕೊಂಡಿದ್ದೀನಿ. Okay, with this particular note, I'm just winding up with my discussion. I'll be coming in my further videos with very interesting concepts. Like normally, like what I believe in is like I would like to prepare videos which will be discussing on the concepts that you get highly confused. You may commit some mistakes, silly mistakes. Those concepts I'll come up with that. Okay, till then you just watch, rewatch this video, enjoy the rainbow color, and with reference to this, I am signing off, your friendly neighborhood teacher Uttam Kumar from Gurudev Academy. Kindly subscribe to our channel, kindly go ahead and press the bell icon and keep watching the videos and share it to maximum number of people so that our teachers' dedicated effort can reach to millions and millions. Thank you very much. Have a wonderful time. See you. Bye-bye.